Whoa, 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 let's go back here. How you doing? This is Mr. Smith. I'm going to run through the second limit test here, hopefully fairly quickly. Hope you get these answers. Hope this helps out. So, number one says f of x is 4 over 3x plus 6, and we want to find pretty much this is the derivative. That's really what that means, but it's the difference quotient, that's this guy here, and h is going to 0. So, hopefully you should have, if you tried this, limit h is going to 0 of 4 over 3x plus h plus 6. That's f of x plus h minus 4 over 3x plus 6. And all that is over one big fraction bar h. Oh, and let me remind you, if you don't have this for some reason, if you weren't in class or you're not in my class at all, you can get this at, there's my plug, advancedmathtutors.com. Here's our logo. It's very pretty. Okay. Anyway, back up to this limit. You're going to plug in h equals 0 first, and it's going to get 0 over 0, which is indeterminate form, which is always going to happen when you're doing a derivative, by the way. That's going to be important later. So now we need to multiply by the common denominator, which is 3x plus h plus 6 times 3x plus 6. All of that's going to be over the same exact thing, because you can only multiply by the same thing on top and bottom. Otherwise, you change what the fraction equals. And what that is going to give us, the limit is still out front, remember him. He's our friend. And the 3x plus h plus 6 over here is going to cancel with the denominator, so you're going to get 4 times 3x plus 6 minus, and on the second fraction, you're going to multiply all this by both of these dudes, and the 3x plus 6 is going to cancel, so you're going to have 4 times, I'm going to distribute the 3 up here too, so 3x plus 3h plus 6. All that is over h times both of them, 3x plus 3h plus 6 times 3x plus 6. And as hopefully you see this, I mean, you know, if you've been in my class or you've done a bunch of these, you know this is going to happen. 4 times 3x, let's change colors here for a second. In color, let's do this color. 4 times 3x is 12x, and 4 times 6 is 24. Then we're going to get minus 12x, 4 times 3x, negative 12x, and minus 24. So the only thing that's going to be left on top, really, is negative 4 times 3h, which is negative 12h. So let's go back to that pretty red color. So all that's on top now is negative 12h over h times all this junk. I'm going to try and squeeze it in there. Plus 3h plus 6 times 3x plus 6. Okay. Now these h's cancel, which is what we needed to happen, so we're going to have negative 12 over all of these things. And as h goes to 0, this term right here, 3h, just becomes 0. So you're left with, let me erase some of this so I can squeeze it in there. Yeah, get out of there. Go, go, go. There we go. Okay, so we'll move up top. We're going to have negative, so limit h going to 0 is going to go away because we're plugging in 0 for h here. These h's canceled, this one turns into 0, and your final answer is negative 12 over, so equals negative 12 over 3x plus 6 times 3x plus 6, which is 3x plus 6 squared. There you go. Alright, number 2. Let's erase all this pen stuff. So there you go. Number 2, find the domain of this thing. Well, you know, when you get a square root, what's inside can't be negative. So what we want is x squared minus x plus 2 must be greater than or equal to 0. Now, to find out where it's greater than 0, we got to try to factor this, and this does not factor. So, luckily for us, or maybe unluckily for you, I don't know how you feel about it, the quadratic formula is going to tell us where this thing equals 0. That's what we need to find. Where's this thing equal 0? X equals positive 1 plus or minus the square root of b squared, which is 1, minus 4 times a times c over 2a, which is 2 times 1. And that's going to equal 1 plus or minus the square root of negative 7 over 2. And we can stop right now because negative 7 is an imaginary number, which means our roots are imaginary, which means this thing right here never crosses the x-axis. Now you know it's a parabola with a positive leading coefficient, so it must open up like this, And if it never touches the axis, then it must always be above the axis. So, since it's always above the x-axis, it's never negative. That means this thing's always positive, which means this thing is always positive. So the square root can always be taken, because x squared minus x plus 2, always positive. So there are no x values that we can't plug in. And the answer, all reals. Okay. Number 3, we're moving. Okay. Limit x goes to 2 of f of x. Let's go over here. Here's 2. You can see from the left side and from the right side they do not approach the same number, so that is does not exist. D, N, E. X goes to 5 from the right side. We'll find 5. Here's 5. Go to the right side of that. So we're looking at like 7 and 6 and moving in towards 5. The graph is up here then. And we are moving along the graph. We're going to keep moving. Da, 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 da. This thing keeps going up forever. As you get closer to 5, this thing gets closer to infinity. That's your answer. See, I'm not doing these in order. ACE. X goes to 2 from the right. Here's 2. Here's the right side of 2. The graph is up here. And if you move closer to x equals 2, you're going to... Hey there, Chief. You're going to move closer and closer to this hole, which is at 2. X goes to negative infinity. I told you, if you see x going to infinity or negative infinity, they're asking for horizontal asymptote. So, just look at the graph here. And you can see, if it's already graphed for you, this should be pretty easy. It's going to get closer and closer to this dotted line that I have nicely put here for us, and that's 2. And we might as well do D. X goes to positive infinity. Same thing over here. This piece is going to keep going and going and going, closer and closer to 2. So, there we go. B. X goes to negative 4. Here's negative 4. You got to check both sides. The right side, which is over here, and the left side, which is over here. Well, on the right side, this guy is headed up to infinity. On the left side, also headed up to infinity. Since they're both going to infinity, the answer is infinity. X goes to 5 from below. Here's 5. Here's the left-hand side of that. And as x goes towards 5, we're moving further and further down. Negative infinity. As x goes to negative 2 from the left, I don't know why I included negative 2 on this, to be honest with you. But it's a gimme question, because here's negative 2, and it's continuous there. So whatever point you get is it. Now technically this is a little bit bigger than 1, but since it's a graph and you can't really tell, just put 1. It really doesn't matter. If this was a real question, like on a test, then I'd have to have this either more obvious, like what value it was, like 2 or 1.8 or something. I mean, it'd have to be easier for you to pick it out. But for right now, 1 is fine for us. Okay. All these limits. First thing you do, you plug in negative 3. If you plug in negative 3 here, you get 0 over 0, which is usually what's going to happen. If you get 0 over 0, that means more work. In this case, we're going to factor it. So we're going to have the limit. X is going to negative 3. The top factors, not x, this should be a g. Who's making these things? My gosh. Okay, g is going to negative 3. So we're going to have g minus 3 times g plus 3 over g minus 3. Same exact thing we started with, just factored. Now these things cancel, which leaves us with just g plus 3, which means g plus 3 looks just like this graph. Very nice. And if x goes to negative 3 on g plus 3, we get 0. So that's that answer. Uh-oh, running out of power here. Okay. B, it's sine x over x cosine x. When you plug in 0, you get 0 over 0. And when you have a trig limit, all you need to do, if you're getting 0 over 0, is try to cancel things out, or try to get to one of the limits we know. And in this case, that's going to be sine of x over x. And we're going to multiply that by cosine x over 1 equals. Now, this fraction right here, as x goes to 0, sine x over x turns into 1. And this fraction over here, as x goes to 0, cosine of 0 is 1. So you have 1 times 1, answer is 1. C, as x goes to infinity, they're asking for, again, the horizontal asymptote. As x goes to infinity, we got the polynomials here, so the answer, finding the horizontal asymptote, you look at the degrees. The bottom is 5, the top is 3. Since the bottom has a higher degree, it's going to get much bigger, much faster, which forces this fraction to go to 0 as x goes to infinity. Alright, over here. X goes to 3, you plug it in, you get 13 over 0. So there's a vertical asymptote there. That's what that means. We got to find out if they're both going to infinity, both going to negative infinity, or if they split. So here's what we're going to do. We are going to first off factor the bottom. That factors into x minus 3 squared. And then you're going to make a number line. And the number of interest is 3. And all we want to know is, as x gets really close to 3, what are the signs of this fraction here? So it's a fraction on both sides. X plus 10 over x squared minus 6x plus 9. And as x goes to 3, the top is close to 13. So the top is going to be positive no matter what. Plus. plus. No problem. And as x goes to 3 on the bottom, if x is a little bit less than 3, well, x minus 3 is a negative number, but you're squaring it, which makes it positive. And if x is a little bigger than 3, this is positive, and you're squaring it, which makes it still positive. So they're both going to be, let's just put positives here. This is a positive, this is a positive. So the answer to this question here, because of this, I'm going to erase all this junk, but because of that happening, the answer to this is infinity. All right. All right, here, x going to infinity, 5 plus 3 to negative 4x. If x goes to infinity, 3 to the negative infinity is getting closer and closer to 0, so you pretty much have 5 plus 0. Oh, I ran out of power. Oh no. Alright, I'm not sure how this is going to affect anything. Let's get out of here. And show. Discard. We don't care about those. And function